Pre-statistics. Using systems to model data. Part 3. Lesson objective. Use substitution or elimination to make predictions about situations described by rates of change. Lesson objective. Example 4. In 2005, a 2004 Cadillac DeVille cost about $26,440. And a 2004 Acura Integra RSX cost about $18,243. The DeVille depreciates by $3,548 each year, and the Integra depreciates by $1,333 each year. When will these 2004 cars have the same value? Our first step in this problem is to identify what's our independent and dependent variables. So if we look at the question, we want to know when will, so we want to know time, these 2004 cars have the same value. So that's our second variable, value of the car. So our two variables are time and value. So which one's the independent? Well, if we think about it, the value of the car depends upon how long, time. Or another way we can think about it is if we look at the information given, it says that the DeVille depreciates, that means gets smaller, by $3,548 each year. Okay, each means division, so it means that it's going to depreciate, which is negative, $3,548 each year. For every 1 year, the cost, the value of the car, decreases by $3,548. This is telling us this is the same thing as slope. So this is our change in y over our change in x. So our independent variable is time measured in years, and our dependent variable is the value of the car. So the next step is to come up with our two models. So we're going to have one model that is the Cadillac, and we'll have one model that is the Integra. So we're going to let V equal D of T, which means that's the value measured in dollars of the DeVille. We're going to let I equal D of V, which will be the value measured in dollars of the Integra. T will be the number of years since 2005. That is going to be our independent variable. And notice we have our dependent variable written in function notation. The DeVille value decreases by a constant $3,548 each year. So that means the slope is a negative $3,548. And since T is the number of years since 2005, and 2005, or when T is 0, this is the value of the DeVille. So it turns out our y-intercept is 26,440. So the equation of D can be thought of as y equals mx plus b. Our dependent variable y can be expressed as v or d of t. Our slope is negative 3,548. Our x, our independent, is t, and our y-intercept is 26,440. For the next model, we know that the Integra value depreciates $1,333, so our slope is a negative $1,333. And again, our y-intercept, when t is 0, which means 2005, the value of the car was 18,243. So again, y equals mx plus b. We have the value of the car equal to the slope times the independent variable plus the y-intercept. So our next step is to use substitution, and we are going to substitute this expression for the DeVille for v into the other equation. So wherever we see a v, we are going to substitute this expression. When we solve for t, we're going to add 1,333t to both sides, then subtract 26,440 to both sides. Combining like terms gives us the equation negative 2,215t equals negative 8,197. Dividing by a negative 2,215, we have t is approximately equal to 3.70. So we conclude that the cars will have the same value and about 3.7, or rounded off, approximately 4 years from 1995, which would be 2009. Our next step is to find the value of each car. So in 2009 they will be the same value, so it doesn't matter which equation we pick. And in this case I'm using the DeVille. So when t is 3.70, I substitute that in for my t, multiply it by the slope, then add my y-intercept, and we get a value of 13,312. So both cars will be worth about $13,300 in 2009, according to the model. We can verify this by using the graphing calculator. We type in the equations in y1 and y2. We adjust the window settings so we can see the point of intersection, and then we use our intersection feature to find the point of intersection, and the calculator is verifying our solution is correct. Example 5. In 2008, the price of a 2007 Honda Accord was about $18,329, with a depreciation of about $2,256 per year. A student had $500 in 2008 and saves $1,700 each year. Assume that the student does not earn interest on his savings. A. Let h of t be the value, measured in dollars, of a 2007 Honda Accord, and s of t be the student's total savings, measured in dollars, for both t years since 2008. Find the equations of h and s. So again, we're going to think of this as y equals mx plus b. From the problem, we know depreciation means a negative slope. So we have m as a negative 2,256, and b is the value of the car in 2008. So we have h of t, that is our y. We have our slope. T is the number of years since 2008. That's our independent variable. And then we have our y-intercept, our b, which is 18,329. For the other function, the student savings, we know that the slope is $1,700, which is positive, and the starting value was $500. So the equation would be s of t equals 1,700t plus 500. B. Use substitution or elimination to predict when the student will be able to buy the 2007 Honda Accord for cash. To solve this, I'm going to use substitution. I'm going to set the two expressions equal to each other. The next step, I'm going to add 2,256t to both sides. Next, I subtract 500 to both sides, and dividing by 3,956, I get t is approximately 4.51. So according to the models, the student will save enough money to buy the 2007 Honda Accord in approximately 4.5 years, or in about the year 2013. To compute the value of the savings or the value of the car, we pick one of the equations. We substitute our t, 4.51, into the expression, and we come out with the value of 8,167. So according to the models, the amount of money saved and the cost of the car is approximately $8,200. Part C, use the intersection feature on the graphing calculator to verify the answer in Part B. So we put our equations in y1, y2. If we need to look at the table to get an idea of the window settings, We can. These are the window savings I'm going to use. -1 for my X min, 10 for my X max, because we know that the point of intersection is about 4.5. For the Y min, I'm using -10 so I can see the X axis. And for the Y max, I'm using 10,000 because I know the value of the car and the savings is about 8,200. So I'll be able to see the Y coordinate, and I'm counting by 500. So this is what my graph looks like. This is the point of intersection, and if I hit second trace and number 5, which is intersect, choose the 2 lines and the guess, the point of intersection according to the calculator is what we got when we solved it algebraically. D. Now assume that the student earns interest on his savings. Is the answer in part B an underestimate or an overestimate? Explain. Well, if the student's getting interest, that means the student is making more money in less time. So that means the calculation is a overestimate. If interest is being made, then the amount of money in the student's account would increase at a faster rate over time. Therefore, the amount of time it would take to save enough money would be less than what the model said in part B. Thanks for watching.